Chapter 7, the dreaded 7-1 that we didn't like because we couldn't decide if order mattered or not. And that was probably the toughest part from that chapter. So, in number 25, let's take a look at this one. We are talking about texting on a cell phone. This is probably before the days of having your smartphone where you just use the keyboard. But if you had you push the number 3 to get different options. What was that called? T9?
Those were the best. See, there was the FN key.
You had to push different numbers to different
FN key.
Okay. So,
And then there was FN lock.
here are their options. When text messaging on an old phone, big flip phone, if you press the number 3, you either can get a D, E, F, or actually the number 3. So you have 4 options if you push that key. If you push the number 7, ladies, you have P, Q, R, S, or the number 7. So you have 5 options if you push that key. So I want to know how many messages, they don't have to actually make sense, but how many different codes, if you want to call it, could you make by pushing a 3, the 7, and then the 3? So first off, will we agree that there are three things we're choosing here? Okay. Since it's going to be like a code or a message, we would say yes, order matters. That's right. Whenever order matters, you're going to put how many things are we doing. So I'm going to choose 3 things here. So I'm going to use that counting principle to find out how many it is. If I press the number 3 first, well, it could have either been a D, E, F, or 3. So I have 4 options for that first part of the code. Then I'm going to press a 7. How many options for the number 7? 5, because it would have been P, Q, R, S, or 7. And then I'm going to press the number 3. How many options there? Back to 4. If I multiply those together, that should give us the answer of 8. Remember, this does not say probability, so there are no fractions here. Just how many ways, it should just be a whole number. Let's try 26. Francesca is taking 4 for 14 books with her on a trip. How many ways can she choose them? Does it matter which order she chooses her books? No. So order does not matter. Now, if you tell me order does not matter, there's a formula you have to use. Does anyone remember what it is?
N over...
N factorial over...
minus R times R.
N minus R out front. Can you please star this? Highlight something. I will not provide that for you. You need to know that formula. Okay? Again, that is not something I will give you. So there are not a ton of formulas you need to know. That is one of them. So in this problem, what is N? What value? N is 4. I'll take it back. N is 14, which means R is 4. The total is the N. That's the bigger number. So when I want to set this up, this is going to be 14 factorial over 4 factorial times 14 minus 4 factorial. Now, we can list those out by hand to kind of figure out what's happening there. Just to save us some room, because I don't have that up here, I'm going to go to my calculator. Close that. Let's open this up. On a calculator page, if I set up a fraction and I want 14, where's that factorial key? It's over by the G. So there's the factorial if you want to do that if you don't want to list them out. So 14 factorial. Then on the bottom it was 4 factorial. And then in parentheses, 14 minus 4 with the factorial on the outside. So you should get 1001. Again, you could do that same thing just by listing them out. I just don't really have a ton of room up here. And that's a good way to check also. Okay, and number 27. There are 8 finalists in a talent show. How many ways can a winner and a runner-up be chosen? Does order matter here? Yes, because it matters if you get first or second place. So if order matters, I'm going to use the counting principle. How many prizes am I choosing, or positions am I choosing? Yes, winner, runner-up. So I have 2 things. So how many choices do I have for the winner?
8.
Perfect. How many choices do I then have for the runner-up? 7. If I multiply those, I get 56 different ways. Questions on that one? Okay. Let's move on to 7-2. 8 teacher is going to write the word mathematics on a piece of paper and cut out each letter separately. I'm going to put them all in the bag. I'm going to draw out 2 letters at random. I am not going to replace them if I did it would be stated there. I want to know the probabilities of keyword and fractions now, or a percentage or a decimal. Probability that I will select an M and then an A. So my first question is, how many total letters are going to be floating around in this bag? 11. So if I want to know what are my chances of choosing an M, out of those 11 letters, how many M's are in there? 2. Okay. I'm then going to choose the letter A. So if I pick one in, I want to choose the right thing. So I'm going to choose an M, put it to the side. What's the probability now that the next thing I pick will be an A? 2 out of 10. What will I do with those fractions? Perfect. Whenever you're drawing more than one thing, the probabilities are always multiplied together. If I multiply that, that's going to be 4 out of 110, which reduces down to 2 out of 55. If you want to make that into a decimal, that's fine. Your choice. Let's try 29. A marble is drawn from a bag. Its color is recorded in the table. What is the experimental probability of drawing a blue marble? So 16 is the numerator. I agree with that. How do I find my denominator? Add them all up. If I add the total, what am I going to get there? Questions? Okay. Let's keep, I know we're done with my section, but let's just keep working on some more since we have a couple more minutes. The more we get done, the better. Number 30. Let's talk about probability some more. I want to draw a face card from a standard deck of cards. I'm going to put it back, and then I'm going to draw a number card. How many cards are in a deck of cards? 52. When I talk about a face card, I mean there's actually a human on it. So that's going to be the jack, the queen, and the king. So out of 52 cards, how many total face cards will I have? Perfect. That's the first part. As far as number cards, well, I want one with actual numbers on it. So that's going to be the 2, 3, 4, 5, 6, 7, 8, 9, and 10 in each suit. How many total number cards will I have? Huh? 36. Since I replaced it with what will my denominator say? 52. Since I'm drawing more than one thing, I'm going to multiply. So I get my total, and then I reduce. Okay, for part B, I want to roll a number greater than or equal to 4 on a number cube twice in a row. How many options does a number cube have? 6. So out of those 6, what's the probability of being a number greater than or equal to 4? 3. So that's 4, 5, 6, right? And I want to make that happen 2 times. So my second fraction should be exactly the same. So 3 out of 6 times 3 out of 6, 9 out of 36, or 1/4. Okay, down to number 31. The table shows the results of a school-wide survey for a homecoming dance. Find each probability. Again, these are all fractions, decimals, percent. A surveyed student is male and prefers the gym. So how many people fit that condition? Let's find our numerator first. Males prefer the gym. 58. Okay, so we're going to see how that reduces down. What would be my denominator? I'm just talking about a surveyed student. I'm going to add the total for all of these. So if I add all 4 numbers, my total for all of this, I'm going to end up with 215. So since it just said a surveyed student, it's kind of generic there, this is the total for the whole table. Now, let's compare that to part B. Probability that a surveyed student who is a survey student who prefers the cafeteria is a girl. So I think our numerator is easier to find first. If I want a survey student who prefers the cafeteria is a girl, what's my numerator going to be then? I heard it. 53. So that's girls in the cafeteria. Now, let's talk about the denominator. It doesn't just say a surveyed student, it's a surveyed student who prefers the cafeteria. So I'm not asking of everybody.
Over 90.
It would be over 90 You're right.
53 plus 37.
So since it says cafeteria prefers that, you're limiting yourself to just this row in the table. So your total just comes from there. So the word prefer, or what's the other word you sometimes see that tells you that? So to the G, I, V, given. So prefers or given, those two keywords change your denominator. Because you're limiting who you're actually talking to. You're saying, I know they prefer this, so I'm going to choose this word. I know I'm only given this group of people. Okay, moving on. Third two. Find the probability of selecting a yellow and then a blue when they're chosen without replacement. How many total beads do we have? 18. How many are yellow?
6.
So my first choice is going to be 6 out of 18. First off, it's dependent because I did not replace. So if my chances of a yellow are 6 out of 18 and I do not put it back, what are my chances for the blue?
5 over 17.
Perfect. And then we'll multiply them together. So if you look at your part B, it's very similar. I want to select a yellow and then a blue, but I will use replacements. That's going to make them independent. How would my fractions change? What would the denominators be for both of them? Perfect. So 6 out of 18 times 5 out of 18. Okay. We're going to do one last one so we can finish this section and then we'll switch. Let's do the geometric probability. Find the probability that a random point within the square is within the inner circle. Well, I need to find the area that's shaded over the total. So to find the area of the shaded, how do I find the area of a circle?
R squared.
Okay, so that's going to be pi r squared. What was my r?
8.
So pi times 8 squared, or that's 64 pi. I don't have my calculator, but if you want to make that a decimal, go ahead. Patrick, did you?
I got 201.062.
201.062? Okay. Alright, my total then, the large shape there, is a square. How do you find the area of a square? Length times width, or the side squared? The length of the side, perfect, is 16. That should be 256. So you can either give me an answer of 64 pi over 256. You could give me the decimal version, or you can make it into a decimal or a percent. I'm pretty flexible on what you give me as far as that goes. Other questions?